Hey everyone, welcome back to another video by Camroom 5. In today's video we are going to be talking about sulfuric acid and the redox reactions of group 17. We know that sulfuric acid is a strong oxidizing agent and we'll see how group 7 responds to it. Group 17 could be the elements or it could be the group 17 halide ions. From fluorine, chlorine, bromine and iodine the reactivity changes because each one wants to gain electrons. They gain 2 electrons, one atom gets 1 electron and they become 2 halide ions. But the reactivity changes based on which reaction is faster and which one is slower. Like fluorine gains electron really easily. Fluorine oxidizes others and fluoride will never be oxidized. Fluoride can't be oxidized because fluoride is very stable. On the contrary, iodine can not oxidize others. Iodine is very weak. So that's why iodine can't oxidize others. But iodide can be oxidized back into the iodine state. So you can expect iodide to be oxidized really easily, especially by sulfuric acid. The reason is very simple, that fluoride is very stable but iodide is unstable, so iodide can be oxidized, even bromide can be. But fluoride is stable. So fluorine is a reactive element which makes fluoride ions, but iodine is the least reactive because it cannot make iodide really easily. To understand this further, imagine 3 test tubes, each containing one salt. Sodium chloride, sodium bromide and sodium iodide, one in each. I'm adding concentrated sulfuric acid into these salt samples. Concentrated sulfuric acid is a very strong acid, a very good dehydrating agent, and of course a strong oxidizing agent. With sodium chloride, you can expect the solid to be dissolving and steamy fumes of HCl coming out. Steamy fumes of HCl, which are obviously acidic in nature, so they will make the overall solution acidic. With sodium bromide, you can expect strong red-brown fumes coming out, and in sodium iodide, you can expect violet fumes coming out really vigorously. So sodium chloride, bromide and iodide have responded differently. Let's understand the chemistry behind that. When sodium chloride reacts with concentrated sulfuric acid, a kind of acid-base reaction happens here. Sodium hydrogen sulfate is made and hydrogen chloride fumes are produced. It's an acid-base reaction, or you can say it's an acid-base and a double displacement reaction. The sulfuric acid breaks down into the hydrogen ions and the hydrogen sulfate ions. Sodium chloride produces Na plus and Cl minus, so it's a kind of acid base and obviously the ionic double displacement. The solution turns acidic because of the hydrogen chloride fumes coming out. When you talk about sodium bromide, the reactions are a little different here. When sodium bromide reacts with concentrated sulfuric acid, sodium hydrogen sulfate is produced like last time and obviously hydrogen bromide. But the hydrogen bromide reacts. This is an acid-base reaction, no doubt, but hydrogen bromide will react with a concentrated sulfuric acid because remember, bromide ions can be oxidized. You will receive bromine gas, which was the reason behind the red-brown fumes, and sulfur dioxide gas. Water is another product obviously in this scenario. Let's talk about balancing this equation to see how many electrons are exchanged. We will write the half equations here. Half equation 1 is HBr producing bromine gas. The second half equation 2 is the concentrated sulfuric acid producing sulfur dioxide gas. The first equation is not balanced even in terms of the bromine atom, so I'm adding a double. The oxidation number changes from -1 to 0, so basically that is an oxidation because each bromide is converted into bromine atom. There's a change of 1 unit oxidation number. That is why 2 electrons are lost overall by 2 HBr. When you talk about the concentrated sulfuric acid, sulfur has an oxidation number of +6, and now it's becoming +4 oxidation number. So that's a 2 unit change in the oxidation number of sulfur atom. You can notice it's a reduction because the oxidation number is decreasing and 2 electrons are gained by the sulfur atom. In order to balance the oxygen, I can see there are 4 and 2 oxygens over there. So 2 oxygens can be added by adding 2 waters. Now the final step for balancing this equation can be to cancel the electrons and obviously add both equations. So in order to write the overall equation, what I'll do is I will cancel both electrons from both sides. I will notice that 2HBr and sulfuric acid are both reactants, while a bromine molecule, a sulfur dioxide molecule, and 2 waters are my products. You can see every atom is balanced here, and that is why this reaction is redox, because there's change of oxidation number. When we talk about sodium iodide reacting with concentrated sulfuric acid, we can expect hydrogen iodide and sodium hydrogen sulfate, like last time. But hydrogen iodide continues to react with the concentrated sulfuric acid to produce iodine and sulfur dioxide gas. The oxidation number for iodide changes from -1 to 0, which is a change of 1 unit. While the oxidation number of sulfur was +6 in sulfuric acid and it's +4 in SO2. Iodine atoms change oxidation number by 1 unit, but the sulfur atom changes it by 2 unit. In order to balance it, we swap the changes. So Hi gets a 2, obviously iodine is balanced, while sulfuric acid gets a 1. SO2 is balanced. Now we can notice the hydrogens aren't balanced yet. 2Hi and sulfuric acid have 4 H's in total, so we can add double waters as an extra product. In this way, the first equation is balanced. This is the very first possibility of Hi. Let's talk about the second possibility where Hi reacts with sulfuric acid. Iodine is the common product, but this time you can expect sulfur, which is pale yellow precipitates. The oxidation number for iodide changes from -1 to 0, while for sulfur it changes from +6 to 0 because sulfur as pure element has 0 oxidation number. Iodide atom changes 1 unit oxidation number, while sulfur changes 6 units. To balance the oxidation numbers, Hi gets a 6 and obviously iodine gets a 3, while sulfuric acid and the product species get 1. We swap the oxidation number changes. You can notice that overall 8 hydrogen atoms on the left hand side can produce 4 water molecules because 4 waters will have 8 hydrogens. That is the second possibility. If we continue to talk about the third possibility, Hi could also react with the concentrated sulfuric acid to produce iodine, which is obviously the common product as we know, but also hydrogen sulfide. Iodide oxidation number changes from -1 to 0, while for sulfur it's from +6 to -2. Iodide has similar 1 unit change of oxidation number, but sulfur has it for 8 units. We swap the oxidation number changes and Hi gets 8. Obviously 4 iodines can be made from this way. sulfuric acid and hydrogen sulfide have 1 molar ratio. We can notice that there are overall 10 hydrogens on the left hand side, but the 2 are present in the H2S. So 8 hydrogens are used up to make water while 2 are already used in hydrogen sulfide. So we make 4 waters as a product here. That is the third possibility. These reactions of HI with concentrated sulfuric acid are redox in nature. Even the hydrogen bromide reaction was redox, but the chloride reaction was not redox, it was acid base and double displacement. So chloride, bromide and iodide have behaved differently. With sulfuric acid, if it's concentrated, chloride will give you only acid-base reaction. So no redox happens here. Chloride minus can't be oxidized even by concentrated sulfuric acid. Bromide minus can be oxidized. So bromide ion can produce bromine because it can be oxidized. Iodide minus can produce iodine because it can be oxidized. The reason is very simple, that sulfuric acid is a strong oxidizing agent, at least strong enough to oxidize bromide and iodide. Now I hope this whole concept is clear for you guys. Stay tuned guys. Thanks.